Assalamualaikum warahmatullahi wabarakatuh. My name is Afzatul Najwa, Binti Azman, and today I will be presenting about my final year project entitled Design and Modification of Shulas. My supervisor is Professor Dr. Solehuddin bin Shuib and my co-supervisor is Dr. Sharimai Ismadi Ismail. Let us start with the project summary. When creating a new shoelace, it is essential to bear in mind the end goal of making shoes that meet the needs of the consumer without losing aesthetic. For this project, we'll be using 3D foot scanner to generate digital foot model, which will later be imported into 3D computer-aided design program to be used in the design of individual shoelace. The shoelace can be adjusted and examined using finding element analysis to guarantee that they are durable and able to handle the manufacturing processes force. This technique aims to improve shoe fit and comfort while reducing material waste in the manufacturing process by balancing biomechanical and aesthetic needs. Next, let me proceed with the introduction. The primary function of footwear is to comfort the foot and reduce the effect of impact during normal everyday activities. Custom-made shoes may be necessary for those with abnormal foot shape. The size and shape of the shoelace is crucial for proper fit and performance. Research has shown that 3D modeling and 3D printing can be used to create personalized, cost-effective shoelaces made of thermoplastic materials. The 3D scanning approach is also more accurate and precise than traditional method of measurement. When designing a shoe sizing system, it is crucial to think about both current foot size and the impact of different generations. This is some of literature review that I researched through the research paper and I selected two of them. The first one is from Marco Marconi and others. They offer a method for constructing digital model of shoelace using computer-aided design software and evaluating the structural behavior of the lace using finite element analysis. The researchers used 3D printing to create prototypes of the lace and tested them for fit and performance. They used a modified shoe lace with reference hole on its surface to establish a calibration matrix. The authors argue that the use of digital technology and 3D printing can help designers create more functionally attractive shoelaces and generate new styles and shapes. As a bonus, it can cut down on design time and expense. The second one is from Kathleen Amza and others. They describe a method for creating custom shoelaces for bespoke custom-made shoes production. Using a 3D scanner, a digital model of the customer's foot was constructed. Computer-aided design software was then used to create a custom shoelace based on the foot model and the customer's demand. A 3D printer is then used to create the final shoelace. The researchers compare 3D printed shoelace to traditional method and investigate the benefit of 3D printing in the footwear sectors. When producing items in big quantities, such as shoelace, it is necessary to invest more time and money into the production process. Proceed with the problem statement of the project. Shoelaces are used to form a primary shape and form of the shoe's upper and a crucial part of the shoe making process. Shoelace improvement for better comfort and fit has developed as a hot topic in recent years. However, making and modifying shoelace can be challenging. For instance, if the foot is not perfectly symmetrical, it could be difficult to capture its true proportion and shape. The material and production technique available for making a lace may also affect the fit and comfort of the final product. This project has three objectives, and the first one is to provide a proper fit for the foot. The shoelace should provide a comfortable and supportive fit for the foot. Second, to identify stress concentration and potential failure points. Finding element analysis can be used to discover shoe areas that are prone to high stress or failure. And lastly, to create a reference model for the final product. The prototype shoes can be used as a guide to ensure that the final product matches to the desired design. The scope and limitation of the project. The goal of the research is to create and improve shoelace for use in the footwear industry. By creating one's own shoelace, the parameter of this project can be specified more accurately. To develop a digital model that can direct the construction of a real prototype, the shoelace is designed and modified with the help of 3D foot scanner and 3D computer-aided design software. Then, the shoelace reaction to loads like the user's weight, impact forces, and lateral forces can be modeled via finite element analysis. The design can be modified based on the prototype performance and testing feedback. This project of methodology consists of 8 primary stages. Firstly, determine the objective and problems of the project. Second stage, analyze published work on Shula's customization and exploration. Third stage, collect important data that will be used in the project. Fourth stage, scan the food using a 3D food scanner. Fifth stage, process the data from 3D food scanner and create the 3D CAD model of the last. Sixth stage, design and modify the Shulas to match the shape and size of the food. Seventh stage, identify stress concentration and potential failure points using finding element analysis. And the last stage is ensure that the final product meets all the design and performance requirements. As for methodology, it will be divided into 3 categories. First is design of the food using 3D scan. The first step in creating a custom feed shoes is to perform a 3D scan of the food to create a digital model of its size and shape. As we can see, there is a measurement of the food utilizing a 3D scan for both the left and right foot. This model is then used to make a shoe last, which is a physical mold of the foot. A 3D computer-aided design program is used to develop or change the shoe last based on the digital model of the foot, ensuring that the dimension and shape of the user's foot are precisely reflected. The computer-aided design software allows for precise modification to the last design as well as evaluating the shoe's fit and comfort. Second category is finding element analysis. Finding element analysis is a computer-based simulation method for predicting how structure will respond to various loading conditions. Following that, the weights and boundary conditions such as the weight of the foot and pressure applied by the shoe upper must be given for the simulation. The final product stresses and deformations are calculated using finding element analysis software. This study can be used to discover design problems and optimize the last to fulfill performance standards by adding or removing material to enhance weight or stiffness. And the last category is 3D printing. After the shoe last design is finalized, a prototype can be made utilizing rapid prototyping techniques such as 3D printing. The design can be exported as an STL file, a common format for 3D printing, and printed on a 3D printer such as the Flashpoint Guide 2. The prototype should be evaluated to determine its quality, fit, comfort, and longevity, and any necessary design changes should be made. This procedure should be repeated until an acceptable prototype is considered. For the expected result of this project, 3D computer-aided design software can be used to create and modify a digital model of a shoe last to achieve the desired size, shape, and fit. The digital model can then be 3D printed as a prototype for testing and evaluation. The 3D computer-aided design software can also be used to align a foot scan with the template for the shoe last and make any necessary adjustment to achieve the desired fit. Computer-aided engineering software can be used to perform finding element analysis on a shoe last to understand how it will respond to different loads and identify potential weak points in the design. To conduct the finding element analysis, the software requires input on the geometry of the shoe last, material properties, applied loads, and boundary conditions. The analysis generates a report that includes visuals and statistics on the stress and strain distribution within the shoe last, which may be used to improve fit and comfort of the final product. A prototype of shoe last is a preliminary version that can be used to test the design and function of the final product and identify areas for improvement. Prototyping allows for evaluation of the size, shape, materials, and performance of the shoe last and can help to identify issues or opportunities for improvement in terms of longevity or performance. Creating a prototype can ensure that the final product meets the customer's needs and requirements before investing significant time and resources into its development. That's all from me. We're moving forward to Q&A session, and here is my contact number and email address. Thank you.